Before NASA began its journey into space, engineers and scientists at Huntsville's Redstone Arsenal were working to give America a ticket to the new frontier. The United States Army had a well-established program in the 1950s, headed by Werner von Braun and his team of engineers. One of the keys to the success of the Army team was the testing facilities here at Redstone. The culmination of their efforts was the launch of America's first satellite. President Eisenhower established NASA in 1958, and in 1960 the Marshall Space Flight Center was dedicated. The Army's test facilities became a cornerstone of the new center. One of the oldest of these facilities is the Static Test Tower, constructed in 1951. The tower was used to conduct almost 500 tests of the Army's Jupiter missile. Later, it was modified to conduct tests of Saturn I and Saturn 1B rocket stages. This stand also tested the main engines for the Saturn V moon rocket. Renamed the S-1B Static Test Stand, it's known today as the Propulsion and Structural Test Facility. 649 tests have been conducted here prior to the stand's selection as a National Historic Landmark. Another important legacy from the Army period, the Redstone Interim Test Stand, has also been selected as a National Historic Landmark. The stand tested the vehicle that powered America's first astronaut, Alan Shepard, into suborbital flight. Nearly 400 static firings were conducted here on vehicles ranging from Explorer 1 and Juno 1 to the Mercury Redstone rocket stages. 1956 saw the completion of 2 additional test facilities. The Combustion Test Cells facility tested scale models of various engines. Presently, they are used for small-scale hybrid engines, such as this 11-inch hybrid motor. The second facility was the Cold Calibration Test Stand. Initially, this structure was used to test the Redstone and later the Saturn H-1 engines. The 14-inch Trisonic Aerodynamic Research Facility began operation in 1957. Rocket and launch vehicles from the Jupiter C through the Saturn family and up to the current Space Shuttle and beyond have been tested in Marshall's 14-inch wind tunnel. This complex uses flow visualization techniques, such as shadow graphs and Schlieren, to understand the forces being generated during supersonic flight. Later, as NASA's emphasis turned toward finding more efficient propulsion systems, the Cold Flow Propulsion Test Complex was built to study the internal fluid dynamics of components such as turbopumps and inducers. The first of the cold flow propulsion test cells was the Water Flow Test Facility, which enables researchers to study propulsion processes more clearly by allowing them to see flow dynamics inside a transparent model. The inducer test loop is a higher speed water flow facility, where the inducer test article is rotated up to 6,000 RPM to actively pump the water. Using water enables visualization of cavitation to improve inducer performance and design. The Turbine Test Equipment Facility has used high-pressure air to test full-scale turbine designs for the Space Shuttle main engine. Currently, the facility is supporting the Space Launch Initiative by testing a full-scale supersonic turbine model. Cold flow testing using air allows turbine models to be heavily instrumented, including instruments mounted directly on the blades. The Nozzle Test Facility is an airflow facility that simulates high-altitude conditions, enabling researchers to better understand nozzle performance throughout the launch trajectory. After President Kennedy's dramatic challenge in 1961, activities and construction continued here at an increasing pace. One of the pivotal structures built to meet the President's goal is the Saturn V Dynamic Test Stand, completed in 1964. The critical testing of the Saturn V moon rocket done here was essential to its unrivaled safety record. The Apollo era saw its use for testing America's first space station, Skylab. Later, modifications allowed the facility to be used to perform testing of the Space Shuttle and for use as a drop tower for microgravity research. 1964 saw the completion of 4 other test facilities at Marshall. Test Stand 300 supported the Apollo, Shuttle, and Space Station programs. Most recently, it was used for the mini-magneto plasma propulsion experiments and the on-orbit cryogenic storage experiment known as Zero Boil-Off. The Component Test Facility, an acoustical research facility used for the Saturn Apollo and the Space Shuttle. The F1 turbopump test stand. This stand was instrumental in testing the massive turbopumps of the Saturn V first stage. The 5 massive engines of the Saturn V were clustered and tested at the S1C test stand, generating an unsurpassed 7.5 million pounds of thrust. The Saturn V first stage required the test stand to have a 12 million pound concrete foundation. With the end of the Apollo era, the stand was modified to perform structural tests of the external tank for the Space Shuttle program. Recommissioned the Advanced Engine Test Facility in 1986, the stand provided an important test bed for the development of advanced engine concepts, including an improved shuttle main engine. In 1998, the stand was reconfigured to test a 900,000-pound thrust Russian RD-180 engine mounted on an Atlas commercial launch vehicle. The stand now has both LOX hydrogen and LOX RP capability. The Cryostructural Test Facility is presently used for testing a variety of tanks, such as the X-33 flight tanks. In 1975, the Hot Gas Facility was built to test the thermal protection systems for the shuttle's external tank and solid rocket boosters. The Transient Pressure Test Article was built to qualify the redesigned solid rocket motors. Continual improvement in solid rocket motors is accomplished at the Solid Propulsion Test Facility. As we move to the next generation of reusable launch vehicles, Marshall's propulsion testing capabilities will help engineers and decision-makers choose the right path for tomorrow's spacecraft. Some of the future ideas for space propulsion are already being tested here today, from solar power, microwaves, ion propulsion, to antimatter. Whether it's an advanced form of today's chemical rockets or the dream of an engineer yet born, it's a safe bet that the test facilities at the Marshall Space Flight Center will be at the forefront of that effort.